Today's daily LeetCode problem of the day is minimum limit of balls in a bag number 1760. For this problem, we're given an integer array nums where the ith bag contains nums of I amount of balls. You're also given an integer called max operations. We can perform the following operation at most max operation amount of times. For our operation, we're going to take any bag of balls and divide it into two new bags with a positive number of balls in each. For example, we have a bag of 5 balls. We can divide it into a bag of 1 ball and 4 balls, or 2 bags of 2 balls and 3 balls. So our penalty for this problem is that the maximum number of balls in a single bag is going to be the penalty. We want to minimize the penalty after all of our operations and return the minimum possible penalty after performing the operations. So if we start with example 1, the penalty when we start is 9. But we have 2 operations to shrink this penalty. We can do this by first splitting 9 into 6 and 3. And then we can split 6 into 3 and 3, so our entire array is just 3's, minimizing our penalty to just 3. Example 2, we see that we do something similar, but for this one we have a max operations of 4. So initially we split 8 into 2 4's, and then we split 1 4 into 2 2's, and then we split the other 4 into 2 2's, and then the last 4 into 2 2's, ultimately leaving us with only 2's in the array, so our penalty is only 2. So how are we going to approach this problem? At first glance, this problem seems tricky, but we can solve it using a binary search on the range of possible answers. So here's our plan. We will first define the search range. The minimum number of balls in the bag is 1. Maximum number of balls is the largest value in nums. And then we're going to use binary search. So by using binary search to guess the possible limit for the number of balls in a bag, for each guess, we will check if it is possible to split the bag using at most max operations, such that no bag exceeds our guess. We'll use a helper function for this, and it's a can divide, to determine if a given limit can be achieved with the given number of operations. We will then narrow our search. If a limit works, we'll try smaller values. If it doesn't work, we will increase our limit to try different values. So let's go ahead and jump into the code and see how this works. First thing we're going to do is build our main function, so that way we know exactly what's going on and how we're going to implement the helper function. So in our main function, it's a binary search. We'll first initialize our integer left, which is going to start at 1. We'll have our integer right. The reason it's 1 is because that's the smallest possible positive number that can be our answer. Right is going to be arrays.stream nums dot max dot get as int. So this combination of functions will check our array nums for its max value, and instead of returning as a string, it will return it as an integer, so we can use it as an integer. And then we'll also have our integer called result, which is going to be equal to our rightmost value, since that is our current maximum. We are going to try and lower that result value, but we'll do that with our binary search. So while our left value is less than our right value, we are going to initiate a mid value, which for binary search very simply is left plus right minus left divided by 2. The reason it's formatted like this and not just right plus left divided by 2 is when you're dealing with extremely large integers, doing it this way simply mitigates the chance for you to exceed your memory or your any other limit or the integer limit. Then we will call to our helper function. So we now have our midpoint between the right point and our left point, and we're going to see if we can get our highest bag of balls to be equal to this midpoint using the max operations amount of operations. So if we can divide, that is our helper function, our nums array to equal our midpoint using max operations, then we can equal our right to our midpoint, because we know that is currently the largest midpoint that we have, or the largest answer that we have. Our result will once again equal right, the largest answer that we have. Otherwise, if we cannot divide it to get our numbers equal to the midpoint, our left will be equal to mid plus 1. So that way we are narrowing our search to valid numbers. After this while loop breaks, we can simply return our result. Now for our can divide function, this is going to be our helper function. It's going to check if we can divide the numbers to equal our midpoint that we've calculated. So we'll do this by first initiating the function. It's going to be a private. It's going to return a Boolean value because we're using it as an if statement. It's called can divide. It's going to receive an integer array called nums. It's going to receive an integer called max balls. It's going to receive an integer called max operations. And we're going to use these values to calculate if we can find our midpoint. So we'll have an integer called OPS, which is going to be our ops. And for each integer n in nums, so we're going to go through each integer n in our nums, we're going to calculate how many operations are needed for the current bag to make it equal to the midpoint. So as we go through each number, we'll calculate the operations it takes to split it to equal our midpoint. So we'll have our operations plus equals our value n, or the current number we're on, plus the max amount of balls, or our midpoint that we previously calculated, minus 1. We're going to divide that by max balls minus 1. So if our operations exceed the limit, we will return false. Otherwise, we will return true. So this is just a simple formula to calculate how many divisions it will take for us to reach the midpoint. So if ops is greater than our max operations, we can return false. Otherwise, we will return true. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you. Follow for more daily LeetCode solutions, and check in tomorrow for the next video.